should really make a thumbnail for these. Good morning, mathematicians and mathematician adjacent folks. Jumping back into Milne, fifth installment of our series. Where am I going here? We're almost at 7K. Almost at 7K subs. It seems the sub count is I've finally kickstarted it again. Before I took a break from office hours and posting semi-regularly, it seems like the viewers were slowly climbing. Good morning, Sergio, Polar Bear, and Ken. And then, yeah, definitely, of course, when I paused, the subs stopped increasing, but now they're slowly inching up again. So, let's see. I definitely made some mistakes in my crackpots video. I've been thinking, is it worth releasing one? I was thinking maybe I'll release one where I talk about the mistakes I made, but then I'm like, oh, should I really go back to those papers in depth? I don't think I want to do that, but I think I should admit my mistakes. What am I going to do for 10K? What am I going to do for 10K? I don't know. I don't have anything planned. I don't know what to... What do other people do? What's a special thing to do? Wear a little party hat? Oh yeah, Ken, sorry, I saw I think you made a comment in one of my videos and I don't think I responded. Congratulations. That's awesome. I'm glad it actually helped. Let's go give some love to your comment. Let's go give some love to your comment. Yeah, that's fantastic. Does that mean you're not going to be answering me or asking me interesting group theory questions anymore? One of your questions led to me making a little short. Well, now, yeah. Is that the last of your quals as well? Are you done? Or you still got more? Okay. So I think we left off somewhere around here. Description of cohomology groups by cochains. So again, this is just standard group cohomology stuff. You can take the commutative algebra qual. God damn, how many quals do you have? You have an algebra qual and a commutative algebra qual? Jesus. Let the man cook. Just let Ken cook. Up here, Galoising your cohomology. Good. That's what we be up here doing. Hello, Nibbleton. Oh, I'm getting better at remembering to turn top chat to live chat. Look at that growth. You're seeing growth on this channel. Yeah. Okay. An element of Hom. Yeah. We got functions. Diabolical title. Well, for the live stream, I think it's good. How odd we just get everything lumped together. Yeah. I did watch your video, Nibbleton. Yeah, I did watch your video. Infinity commutative algebra is fun. Working through the first chapter of algebraic geometry and arithmetic curves right now, and you're getting good at tensor and flatness and such. Nice. Yeah. I would say I only understood those just enough to get by. I would definitely one day want to have a better understanding of those concepts, a deeper understanding. You can take a qual on any graduate math class. I mean, that's kind of cool. Well, I'm glad you're having fun. Anyways, Sergio Polar Bear. Nice. Everyone loves their eigenvectors and eigenvalues. Oh, he meant O as O. Yeah. Okay. I started thinking afterwards after he said the rest of it. I was like, I don't know what about that is infinity, but I mean, because there is. I mean, isn't there basically like infinity commutative algebra? You look at what's that ring, E sub infinity, and you look at like the categories of like differential graded. It's E infinity algebra. Yeah. Anywho. Okay, so we got our cochains, cocycles, crossed homomorphism, and our principal crossed homomorphisms. That gives us our H1. Look, we even are talking about the relationship with extensions here. Wow, maybe I should have been looking at Milne for this. I kind of like... This looks like a nice exposition. So this, hopefully I'll be making some videos on this coming up. That is more understandable. Hopefully a video that Sergio Polar Bear on group extensions can understand. And using it as a means to discuss, to inspire cohomology. The definition of cohomology, perhaps. Right now, you're 2 of 4. Okay, halfway mark. Past topology and algebra 1. Now you just need an algebra 2 and analysis. Nice. I mean, have fun with it. Which can sound weird because it's stressful, but yeah, have fun with it. You may come to miss the days when you just had to like sit down and like grind algebra and analysis for hours a day. You're totally super good enough at math to be doing infinity stuff. Yes. I believe you, NPs. I believe you. Z2 graded, good. You managed to convince your department to let you take graduate topology and algebraic topology 1. Hell yeah. Don't let them down. Show them. Rock their world. Show them they made the right choice. Yeah. We love to see that sort of thing on this channel. Taking advanced courses, we're all about that. Oh, interesting. He works it out for the cyclic group here. So he says, if this is cross homomorphism, and if you take powers of an element, you get this. So if G is cyclic of order F, generated by sigma, then a crossed homomorphism is determined by its value m, its value on sigma, and call that m, which satisfies this equation. And conversely, if m in m satisfies that, then it's in here. So principle if and only if that. for a cyclic group of finite order, we've shown that for a choice of generator, we get this isomorphism. Yeah, nice. Yeah, modules are fun. There's so many, yeah. Algebra 2 electric boogaloo. I always go back and forth. There's plenty of times when I've made notes for a course and I've written, if it's something 2, I either write electric boogaloo or I write the reckoning. That's also a favorite of mine to call part 2. The module series is also one I need to get back to eventually, but there's only so many hours in the day. Off topic, you found an anime called Fermat's Cuisine and has actual math in it. And the author glazes Mochizuki hard. Nice. We love to see that too. A very unexpected place where cohomology pops up is in universal algebra. I don't feel like I know enough about universal algebra to be surprised by that or not. But classifying extensions and obstructions somehow. I mean, that is very cohomology. It's giving cohomology, babe. In reasonably nice classes of algebraic structures. Nice. That sounds cool. Algebra 2, the algebra strikes back. Yeah. Somehow I feel like that's, I don't know, 2 on the nose. Also, shouldn't that be algebra 5? Algebra 5. Second cohomology and extensions are not super unexpected. No. Well, yeah. Matter of perspective, though, right? Yeah. Again, I don't know. I'm sure it is surprising. I mean, I'm surprised. I certainly didn't know that fact before, but yeah, I don't know enough about. I gotta turn my red light filter off. Gotta get good sleep, guys. Gotta have your red light filter on at night. Dreading learning differential forms? No, differential forms are amazing, Ken. If you like algebra, it's just a very nice algebraic tool in geometry. Yeah. Oh, Ken, you're going to have fun. Trust me. You're going to have fun learning differential forms. Trust. So we've got, if we have a short exact sequence of G modules, the boundary map has the following description. Oh, okay. So say gamma is given by an R cocycle phi, represented by phi. There exists an R chain lifting phi. Okay. Wait, what does that mean? Hang on. What does it mean by lifting phi here? Because n maps into P. It's just like pre-composition with the inclusion map into P. Oh. You gotta entertain yourselves for a moment. Okay, just told a friend we'd go for coffee today. I forgot to set a time. Differential forms are very boring and easy. Ooh, Boris. Boris. How dare you say boring? Low-key dreading analysis in general. You shouldn't. Analysis is fun. Analysis will turn you into a real mathematician. I guess that's why you're dreading it. That book is the only place you find mention of it. Oh, the book for universal algebra, I guess. Definitely want to read Botan 2. Yeah, I think it's good supplementary material. It's I don't know, a little loose and conversational in some sense, which makes it very good to understand what the hell's going on. But actually, no, it's just pretty good overall, I would say. Yeah. I would say, Ken, that's not a terrible idea. You could read Botan 2 for inspiration and go back to Baby Rudin. Yeah. Or just read up on them in Lee. That would be yeah, that message pop-up is a security risk, I suppose. I don't know how I tell WhatsApp to... Thankfully, none of my friends usually text me with my my credit card number on screen or something. So I think I'll be okay for today. But I'm going to turn it off. Baby Rudin ain't it for differential geometry. Yeah. Right. So this should just be, but yeah, phi saying that it has a lift. Basically, I mean, the argument is just that the phi tilde composed with the projection is phi, right? And I guess because P is projective. I guess we're using the fact that P is projective there. Yeah. Okay. And then the claim is that this thing... and then we take the differential of that thing. Okay. This gives me a thought, though. I mean, the lifting condition from projective modules isn't exactly constructive now, is it? I mean, it just says there exists. But I wonder if anyone's done any work into like constructive algorithms for such a thing in practice. Yeah, I mean, if that's the book in the exam syllabus, then you probably do want to spend some time with it and solve specific questions from Rudin on the differential forms. Oh, okay, we're getting into some Galois cohomology right away. Some number theory, baby. Of the field K. Is K any field? Is K any field right now? I don't know if he set conventions to number fields. All lifts should be homologous, probably. Yeah, I mean, I think that's part of this claim, right? Because, yeah, I mean, I think that's embedded in this claim. If you're saying that d phi tilde is the cocycle representing this, then I think it means that it doesn't depend on a choice of lift. So finite Galois extension, LX and Lx are G modules. Let L over K be a finite Galois extension with Galois group G. In the K theory of Z has some number theory consequences. The K theory of Z? What do you mean? What do you mean? Of the... yeah, what do you mean the K theory of Z? Of the integers? But what's the K theory of the integers? Like of its category of modules? Hello, Samwise Gamgee. Oh, K theory of a ring encodes special values of Dedekind zeta function. What about non-Dedekind domains? I mean, they don't have Dedekind zeta functions. But so K theory, right? Because I mean, the K theory of the ring is the K theory of the, modules over that ring, and a subcollection of those are your invertible sheaves. Something vaguely like that, yeah. Higher K groups of Z, I see. K4 of Z is open, wow. Crazy. You'd think that would be like the easiest ring. Oh, K4 and K6 are not. K5, that one's mine, baby. I'm coming for you, K5. Okay, phi is a crossed homomorphism. So in multiplicative notation, it means this. And we have to find a C in L cross such that phi gamma is equal to this. Right. Because that would be... because we're actually applying this lemma right here, right? No. That's only for a cyclic group. Right. We're just using the definition of the differential of a one cocycle, right? Let's see. What was it? Crossed homomorphisms. Oh, right. Yeah, the principal crossed all look like that. Yeah. What year am I in my Ph.D.? I'm in my 4th and final year. No, I'm in my 5th year. I'm an old man. There's a paper on K8 from 2019. Yeah, is there... so I take it it's not Mrs. information? I don't know what I'm saying. Yeah, exactly, Ken. I was thinking about homotopy groups of spheres as well. So for A in L cross, let B be these actions of A. If B is non-zero, then tau acting on B is hang on, why is that true? Phi sigma A. And this is over sigma and G. Is that what we're going over? Yeah. And then we're applying tau. We also have this rule. I really got to find a way to have both of these screens at once. I can draw on PDFs, right? No, I don't want to. That's going to be too messy. Yeah, sigma comes out and sigma gets eaten. So then tau b will be the sum of tau phi sigma a. But now we can use this formula, and I could say that tau phi sigma should be minus phi tau sigma minus phi tau, right? Is that what we're applying? So minus phi tau sigma, but that's not what he had. That's not what he had written. Oh, and then there should be a sigma out in front of each of these on this side here. Yeah, why did tau? I don't get why tau came out there. Yeah, am I crazy, chat? What's why am I wrong? Why is Spectra that much easier to compute than spaces? I still don't really get Spectra. I've looked up the definition 100 times and I go, okay. And then I forget everything. It's because that's what happens when you don't do exercises about the things you're learning. Yeah, chat, I'm losing my mind. Why is the second tau here? Phi's across homomorphism. Well, I am personally attacking you, Boris. Yeah, that wasn't just general advice. That wasn't me commenting on my own failures. I was just targeting you specifically. Ooh, sorry. Right. I mean, this phi sigma is just an element of the abelian group. It's just an element of the abelian group, right? So, okay, yes, I understand what's happening. Right. This is just an element of the abelian group. So we're just breaking this apart using the product. Like, this is just a homomorphism. It's a very silly mistake on my end. Yeah. So this is like tau of phi sigma a, and then tau. We're just using the homomorphism property. The dot confused me. I saw the dot and I was thinking of an action. Okay, makes perfect sense. Yeah. Okay. Right. So then, Then what are we doing? Then we're applying this rule. Then we're applying this rule to the tau sigma, tau phi sigma, like I did before, which leaves us with this. And then why does it cancel out? 5 tau sigma A. Why does this just work out to be B? Why does this work out to just be B? Oh, because well, this term, I see. Oh, yes, I see. We pull out the phi sigma in front of the sum, and then we've just shifted everything by tau sigma. So this gets pulled out in front. Everything left inside is still just the sum, and so it's phi tau inverse acting on B, and then we get the claim. Nice. And it remains to show that there exists an A. There exists an A for which B is non-zero. Huh? Why? Oh, because we want to find a C that satisfies this. Right. So we'll get that if we can find an A for which this is B is non-zero. And then we use the independence, the linear independence of homomorphisms to get this. When we apply this to the homomorphisms between here, this can't be the zero map. And we're done. Okay, nice, beautiful. Yeah, okay, so that's where we're going to leave it for today. I gotta go have some more coffee with a friend. And I will see you all tomorrow when we prove some more Galois cohomology stuff. Also, Rod, I really want to better understand that statement one day, that spectra are spaces inverted or localized as spheres. But we'll come to all of that.